Well, hello, my friends. We continue our journey into the realm of probability. In these first 5 videos, we're examining terminology, symbols, rules, algebra of sets, and in this last little of the 5, we will just briefly examine De Morgan's laws, which we will use as we go into our study of probability. After this, we will actually begin examining probability theory itself. So let's start out with De Morgan's law. De Morgan formulated 2 powerful laws about the complements of unions and intersections. Now, law, that means a rule that always works. Complement. A complement of a set is everything in the universe that is not in the set, and we're talking about the complements of the union of 2 or more sets or the complements of the intersection of 2 or more sets. Let's try this in symbols. Here's the symbol. Now, as you look at this, pretend you're an alien in the future who's landed on Earth. Mankind has long since become extinct, and you discover this. How in the world would you know what it means? Does look rather ominous, doesn't it? But let's see if we can unravel it. First of all, parentheses tell us that there's something in here. And this means we're going to take the complement of what is in there. This is the complement of a union of a series of sets. So this is the complement of a union equals the intersection of the complements of the little sets themselves. Let's see if we can draw this out just a little bit better where you might understand it. The complement of a union is the intersection of the complements. Let's see if we can do that just a moment. It might make sense. Here we have the complement of a union of a series of sets equals the intersection of the complements of the actual sets. Again, the complement of a union is the intersection of the complements. Let's look at this in Law 2. Law 2 is very similar, and Morgan said that the complement of an intersection is the union of the complements of the series. So the complement of an intersection is the union of the complements. Let's again draw that out into words. The complement of an intersection is the union of the complements. And here we would illustrate it in graphic form. The complement of the intersection of sets is equal to the union of the complements of the sets. So the complement of an intersection is the union of the complements. Those laws are very similar because the complement of a union is the intersection of complements. The complement of an intersection is the union of the complements. You should be able to remember those rules. Again, I want to thank you very much for your support. I hope these videos have proven to be beneficial. May the odds be ever in your favor as you journey through the land of probability. Have a good day.